2019 Nissan Sentra, doing a recovery for a collision repair. It was hitting this corner right here, and you could slightly see the slight bend right here where the collision impacted here, coming in this direction. So the condenser will be replaced, and I already did the check on the refrigerant. It's 100% pure R134A, so we have no problem there. And as you can see, I don't print out the printouts. I do everything through PDFs on my customers' invoices or receipts. So I take a picture of the actual print of the display of the testing of the refrigerant, and it goes in PDF form to all my paperwork, because my paperwork is paperless. I haven't used paper in over a decade. So that's how I do that. And you always could tell it's just about lunchtime right now. 1, 2, 3, 4, 5, and every day I get a little thing like this. Every time I do a recovery, I get a little printout like this. So we're just hitting lunch in about an hour, so I've done 5 recoveries already, just recoveries. And let's get this started. Okay, so remember, recovering refrigerant is part of your diagnosis. You don't know, since this is in a undrivable mode and I cannot test the refrigerant or the AC system whether it's working or not. One thing you want to know is how much refrigerant did you take out to determine if it had a problem before you worked on it. Yeah, if you're ever a shop, you ever have a customer say, oh, my air conditioner was working great before you touched it, but you did a recovery and there's only 2 ounces out of 2 pounds. Yeah, right, Mr. Customer, I don't think so. So we have no leaks here due to an accident. The only thing that happened is just this little tiny dent there, that's all. So there's nothing that could affect the air conditioning performance in a collision in this way, unless it cut through a wire that went to a temperature sensor, and that would stop the AC from working. If they have their little temperature sensor down here somewhere, sometimes that wire will get damaged. But in this case, all the lines that could get damaged or sensors that could get hit and broken off are on this side. And the compressor, as you can see right there, it'll focus. Always look at your compressors and the labels on your compressor to determine what kind of refrigerant oil is going back into the compressor that you're working on. There is no universal snake oil bullshit, one oil for all systems, okay? Get that out of your mind. That's a sack of shit sales and marketing a-holes selling guys BS. That's just like there's the one all universal coolant for engines, the one all engine oil that could go in all engines, and that one all transmission fluid that could go into all transmissions. What? You say there is no such thing? The same BS SOB shit goes for refrigerant oil too. So stay away from the snake oil products. Yes, they will work. I could put salad dressing oil inside this engine and it will turn over, and the customer will be able to drive away with salad dressing oil in there. And I could do the same thing for the transmission. It will shift and they will go away, but what will be the longevity? I can stick 0.16 weight engine oil in a 1969 one-ton Chevy 454 pickup that needed 2050 viscosity weight. I could put 0.16 weight engine oil in that truck, and in the morning that customer will be able to start it up and he will be able to drive away. And you could do the exact opposite, but how long will the engine last? Exactly. But guess what? Nobody will ever blame me, because they'll never think that putting the wrong viscosity oil in a system will cause damage immediately. It'll be far off and you'll never know who to blame. That's why the snake oil manufacturers get to sell snake oil and say, hey, there's this one oil, you could stick it in everything. Okay, get off that subject. Let's start this recovery. Let's zero out my gauge. Come on, zero. Take the weight, make sure it works. We can read up. Now let's read down. Let's take it off. And we read down. Get rid of that little 5 there again. Okay, so I have the unit on. We see there's 59 psi of refrigerant in the system. I'm going to recover off the low side because I don't want to suck out liquid. This high side line is on the liquid side. So if I recover real fast and rapidly, I could remove a lot of liquid really fast. But in automotive, there's also a lot of oil in that refrigerant that will be taken out with that refrigerant. Don't want to do that. That's why, unlike HVAC, we're going to be pulling off the suction side only. It's slower, yes, but this is how you do it in automotive, not like commercial HVAC. All right, so let's open this up and see how long it takes. We are at 0. We're on the scale. It's on. This is off. Let's open it up and watch the numbers. There we go. And it's going. So now, let me close up this one. I did not dial down this one, so it's just reading the pressure on both sides. So let me close off the high side so I could read what the high side. If I know I'm below my saturation or above my saturation point for what the temperature is, I know I won't suck out. We're at 33, I'm good to go. I can open up this and I know for sure I will not suck up a liquid. So this is down, this is up. I'm now gonna open up the low side and I could look inside the glass port, and it did not saturate with a big splooge of liquid coming out of there because I knew I was below the point where liquid refrigerant can even exist inside this high side line that's normally filled with liquid. That's just one of the gas laws, something you're supposed to know, something you learned back in HVAC class, what everybody of course went to. Just playing with you guys, sorry guys. All right. So we're almost good to go, and we're getting down there pretty fast. And I could turn this down to vapor now. I'm way below the area where it could go. A few more minutes and I'll be done. So I will catch you guys on the next video. And remember, when doing recoveries on automotive, gotta stress that, take it off the low side, not the high side. And always look up what kind of oil is needing in your compressor. So when you're adding oil for replacing a part, so for like replacing this particular manufacturer type condenser that has the condensant bag inside here, desiccant bag inside here, which is like a big sponge, it absorbs some oil in it, and so do the tubes inside have a little oil residue that's left behind. So when this gets replaced with a brand new dry condenser, I'll be adding back say 45 or 50 milliliters of the manufacturer's specified refrigerant oil to the system prior to charging it up. You always have to compensate for that. And if you want to know the specs, you go to the spec book for your manufacturer and look up what is recommended for every component change. Like say the compressor was hit and there's a hole or a crack on the compressor, you're going to take it off. Well, if you're taking off the compressor, I might be removing 3 ounces of oil. And then you have to check whether the new compressor comes filled with oil for the whole system, filled with oil only enough that's supposed to be in the compressor, or it comes empty. Because they come different ways, empty, partial full, or full for a whole system. You need to know that. All right, see you guys on the next video.